we're going to convert complex numbers to polar form. So the form of a complex number is always the same. It will always be a plus bi, where a is the real part and b is the imaginary part. So here a is equal to 5 and b is equal to 3. So for a polar number, what we have to do is rewrite that. We know that a is equal to r times the cosine. B is ir times the sine of theta. So what we go ahead and do is we take our complex number. Our complex numbers are called z. So to convert the complex number z into polar form, we need two different things. If we look back up at the equations for polar, you see that the two things that we need are both r and theta. The next slide we'll go ahead and do two examples. So we're going to go ahead and convert negative 2 minus 2i to polar. So to do that, we have to find theta. So to find theta, the first thing we do is we take the tangent of theta is equal to b over a. In this case, we do know that because z is equal to negative 2 minus 2i, that a is equal to negative 2 and b is also equal to. So what we have here is that the tangent of theta is equal to negative 2 over negative 2, or equal to 1. So the tangent of theta is equal to 1, and that happens when theta is equal to pi over 4. Next we find r. R is equal to the square root of a squared plus b squared. So r is equal to the square root of negative 2 squared plus negative 2 squared. So r is equal to 4 plus 4, or 8, and 8 as a radical is reduced to 2 square root of 2. So our final answer, we're going to put that back into polar form. So our polar forms of an equation is always going to be r cosine of theta plus ir sine of theta, so that now we know what theta is, pi over 4, and r is square root of 2 over 2. I can go ahead and write that as 2 square root of 2, parentheses, cosine of pi over 4 plus I sine of pi over 4. You could also write that as 2 cis cosine I sine of pi over 4. So we're going to go ahead and start by finding theta. Take the tangent of theta is equal to b over a. And then we're going to go ahead and find r, which is the square root of a squared plus b squared. So a in this case is equal to negative 1. B is equal to the square root of 3. So to go ahead and find the tangent of theta, the tangent of theta is equal to 3 over negative 1, which is negative square root of 3. That happens at theta when theta is equal to, if you put it in the calculator, you're going to go ahead and get negative pi over 3. Now, unfortunately, that's not the value we want. That's the reference angle that we want. So if we take a look at what happens here, we can see that that is going in the opposite direction. So that would be down there at negative pi over 3. That also is the same angle as 2 pi minus pi over 3, or 5 pi over 3. That's still not the angle we want, because at the same point in time that happens at another place, and that happens in the second quadrant. We can also find that at pi minus pi over 3, or that angle happens at from the 2 pi over 3. That's the first time it happens, and that's the angle we want to use in this case. All right, so the next thing we need to find is the radius. The radius is equal to the square root of -1 squared plus the square root of 3 squared, or the r is equal to 1 plus 3. R is equal to the square root of 4, which is 2. So to go ahead and write this in polar form, we say that is r cosine theta plus I r sine of theta. So we put in the numbers we found and we get 2 cosine of 2 pi over 3, or 2 cosine I sine of 2 pi over 3.